Hi everyone, I'm going to go over question number 24 from the chapter 14 bingo problems. This question is pretty simple. It says for the oscillating object in basically this graph, what are A, its maximum speed, and B, its maximum acceleration? So we'll start with part A, and we want to know the max speed. And the way we do that is we know that the max velocity is equal to the angular frequency times the amplitude. And so we need to find the angular frequency and the amplitude. So let's find the angular frequency first. So we know that the angular frequency is equal to 2 pi over the period. And so now we need to solve for the period. And we know that the period is the amount of time that it takes for one complete cycle to happen. And so in this, it's about 16 seconds is my guess. About as close as I could think. So that means that this is going to equal, our angular frequency is going to be 2 pi over 16. If we simplify the fraction, we'll get pi over 8. Now, if we want to, simplify this even more, we can put in our calculator and we get that to be about 0.39 radians per second. So that's our angular frequency. Now we need the amplitude. And the way we do that is we look from kind of the middle line and see the extreme. And so we can see that it goes from the 0 point down to -10 and also to 10. So we know that our amplitude is going to be 10, and it's in centimeters here. So our A equals 10 centimeters. So now we have everything we need to find that maximum velocity. So we go back here, and we know that our maximum velocity is equal to, say, 0.39 radians per second times 10 centimeters. And so now all we have to do is multiply these together, and we will end up with 3.9 and it's not meters per second, it's centimeters per second. So that's our maximum velocity of this particle that's going through this rhythmic function. So I'll write that up here. So we'll say all right. So now part B wants to know what the maximum acceleration is of this object. So we know that, well, first of all, we'll just write max acceleration. So we know that, we call it A max, it's going to be equal to negative angular frequency squared times the amplitude. And we do that, we're able to find that through the antiderivative of the velocity function. Sorry, my brain went blank for a minute. So anyway, so we have this equation now, and we already know our angular frequency and our amplitude. So now we can just plug in what we already know. So A max is going to equal negative, we know that our angular frequency was equal to 0.39. That squared times 10 centimeters. And when we plug that into our calculator, and this is rads per second. When we plug this into our calculator, we end up getting that the maximum acceleration is going to be equal to negative 1.5 centimeters per second squared. So that is our maximum acceleration. So in conclusion, we were able to use equations, so we know from chapter 14, and what we know about waves and their periods, amplitudes, angular frequency, all of that, to be able to find the maximum velocity of this object and also its maximum acceleration. So anyway, I hope you learned something. I hope you enjoyed watching this, and we'll see you in the next video. Thanks for watching.